Coming up next on This Week in Radio Tech, gentleman engineer Mark Persons talks about mentoring an engineering student from 150 miles away, custom EAS relays, plus 4 dB steps in some car radios. Crazy. And car buying advice that you won't want to miss from an experienced engineer. Plus, Chris Tobin joins us from the Government Video Expo and Drone Show, all coming up. This Week in Radio Tech is brought to you by Direct Current Broadcast e-newsletter. Get Direct Current in your inbox every Thursday with technical pointers putting you and your facility at an advantage. And by Lavo and the Crystal Clear Virtual Radio Console. Crystal Clear is the console with a multi-touch touchscreen interface. Hey, welcome into This Week in Radio Tech. Kirk Harnack along here, your host, and I'm delighted that you have decided to download or watch the show live. Speaking of, by the way, but this is the show where we talk about everything from the microphone to the light bulb at the top of the tower, and I have one of those in the room, but I've been saying for 4 or 5 years I need to hook it up. Someday I really need to hook it up. It's over in the corner over there. It's a 300 millimeter code beacon. We'll have it on one day. We talk about everything in radio, from audio technology, RF technology, digital stuff, lots of digital audio, coded audio, linear audio. We get all kinds of stuff. So that's all coming up. Our guest today is Mark Persons. I'll bring him on in just a minute. A quick program note, though. Chris Tobin is not joining us live today, but he was at a very cool event in Washington, D.C. And so he's going to be providing a little quick video update of what he saw in Washington, D.C., a show for, well, we'll get to it in just a minute. Let's go ahead and bring in our guest. Mark Persons joins us from Brainerd, Minnesota. Hey, Mark, welcome in.
Well, thanks. It's great to be on with you again. I had a wonderful experience the last few times, and it worked out great. Let's do it again.
Well, and here we are. So I'm glad that you could make it. Understand Paula is back there taking care of whatever you can't, because you have to sit still in the seat right now.
That's right. She's the photographer tonight. So what I do is she takes the photos, and I have to give her credit for it. And then it winds up on my website as I did this, and then a link over to TWiRT.
Okay. Well, good. Well, thanks very much. We appreciate the link anytime. So we're going to jump into the show here pretty quickly. Mark, let's kind of set the show up, and then we're going to take a quick 1-minute break to hear from Chris Tobin and what he did today, and then we will jump into these topics. So what do you want to tease topic-wise? You've got a few really interesting things here to chat about today.
Well, I wrote a list, and at the top of the list, you and I both know Hal Neller, and I was talking with him today. He's down in Florida, and I have some interesting stories to go with that, too. But he said to say hi, and you might know him. Interestingly enough, I built a radio station in Fort Myers, Florida, an AM 3-tower directional, back in the early 80s, mid-80s, and he wound up working there as an engineer to help out.
Gotcha. Well, it's a small world. It's amazing what we come across. One of the key things I think we're going to talk about, and I'll tease it here for you because I really like this subject. It appears that young whippersnappers are designing the volume controls on car radios, and they're not doing it right.
That's right. They're not, because first of all, they're young. They're probably in their 20s, and for Ford, they've hired Microsoft, and the Microsoft people. Have you ever seen a Microsoft guy who has white hair? I don't think so.
I guess not.
So their first iteration of their car radios had 7 decibels per detent step on the dial, or on the 7 dB. Now, as a broadcast engineer, that's like way out of the ballpark. So they came back and they fixed it. They changed it to 4 dB.
We'll tell you what, you got a whole story about that and comparison with other cars. So we'll get to that in just a minute. So we got that and other topics to talk about. That Ford Sync. We're going to look back at radio coupons, FM Extra. That was a technology that I thought was really cool and didn't go nearly as far as I hoped it would. So we'll have that coming up also. And a little interesting thing about used cars and car radios. A little advice that Mark has. And I like to do the same thing with rental cars. We'll check into that in just a minute. So our show, we got a couple of sponsors brought to you in part by the folks at the Telos Alliance and the Direct Current newsletter. We'll hear from them in a bit. And also brought to you in part by Lavo and their line of networked audio consoles. So we have normally right now is when we bring in Chris Tobin. And Chris made a trip to our nation's capital today, and he files this report from a really cool show. Let's go ahead and see that now.
Well, hello, it's Chris Tobin from This Week in Radio Tech, and I spent the day here in Washington, D.C. at the Government Video Expo and National Drone Show. So let's check out what happens when you do one of these things. First of all, we see our friends at ComRex with their live shot video. Can't forget that. And then there's Panasonic with their point tilt zoom cameras, PTZ. And then if you're doing more video transmission and processing, there's EVerts. And there's also the folks who give us more pan tilt zoom. So we continue on with now the look at what we're here for, drones. It's all about the drones. Check it out. DJI, and there's a few others out there. Unique. So if you want to know more, go to gvexpo.com for all about that. And next week we'll talk more about the Government Expo video show. I'm Chris Tobin. This Week in Radio Tech continues with Kirk Honack.
Thanks, Chris. So he had a good time at this drone show. He was telling me about it. Drone and video. So good combination. We're going to hear more from Chris next week. And I can't reveal much about it yet, but over this past week, I got to play with a friend's drone. And it was my first experience with a drone that, frankly, didn't cost $50. This was a real drone in the $1,000 range, and I had a good time with it. I can see a lot of benefit and value there, although I have got to go out and get my drone operator's permit, that Part 107 permit. As a licensed pilot, I should be have a little leg up on getting that quickly, but there you go. Mark Persons is with us. Mark, you, Paul, or any of your folks there ever use drones, either for fun or radio business?
No, I haven't, but a local photographer demonstrated his very expensive one with a Nikon camera hanging under it. I mean, he probably had $15,000 wrapped up in this machine, and he explained how this is not for the faint of heart when you're controlling it and things can go wrong. So, but that was a very vivid experience, and it was great. But I can see where drones have taken off. Sorry to say that, and it doesn't do much for me, but it certainly does a lot for other people.
Well, I know that there are engineers who, like me, like a lot of guys, looking for an excuse to buy a drone, and so they are experimenting with at least some rudimentary tower inspections before you get the crew to go up. At least fly up and have a look. And today's drones do remarkably well holding their position in a wind, even in a bit of a changing wind. I was been delighted with this particular one that I'm using, and it's an older one. It's 5 or 6 years old, and yet you come over the top of a rooftop, and it might move around 2 or 3 feet, maybe 4 feet at the most, but then it regains its position and hovers there, does what it has to do to stay in the same place. And of course, if you're inspecting a tower, that's a pretty valuable thing. I've seen some videos just recently. Well, I saw one of an abandoned AT&T tower in the Nashville area. Some close-up drone. I say close-up. It was probably 20 feet away, but it's absolutely gorgeous. And you know, Mark, have you ever climbed towers? Has that been part of your experience?
I like to climb. It's not my job. Never has been my job. But I don't mind the heights. I find it rather interesting. And I even have a full OSHA climbing harness that I use on my own ham tower that's only 65 feet tall.
Yeah, I think 65 feet will kill you too. But yeah, you know, about 3-4 years ago, I posted a few pictures online of me climbing a little 25-foot tower, like a Roan 25 it may have been 30 feet tall. And I didn't have an OSHA climbing harness. I had the usual belt that I've been using for decades, actually. And ooh, did I get the blowback on Facebook? Oh, Kirk, you better use an OSHA climbing harness. And so I looked into it. I bought the climbing harness. I'm really happy with it, and I used the safety hooks all the way. Even though it's a lot of pain, it's a lot less pain than falling. But I was at a recent SBE Day of Learning that they held in Norfolk, Virginia, And we were informed of the myriad of rules now that tower companies have to abide by to meet all the OSHA standards. And, you know, I think it's about to the point where an individual just about cannot climb legally.
Oh. Well, yeah. I was hearing even 5 or 10 years ago that half of the price that a broadcaster will pay for climbing, half of it's for insurance.
That doesn't.
You hire a company, and the guy who does the climbing, he earns next to nothing.
Yeah. I've heard a lot of stories about, especially if cell towers have a big build out, they'll hire a bunch of pretty inexperienced men, anybody who or women, but anybody who wants to work and climb, and the pay there, the starting pay is awfully low. But I do know some tower guys who do make a good living, but they do a lot of other things too. So
there's more to the story though, and that is that I was talking to a tower contractor the other day, and I said, "Well, where do you find guys to climb? A lot of people don't want to climb." Oh, he says they're everywhere. He says they come into me all the time. They want to climb. He says, but I got a problem. The first thing I ask them is, "Do you have a driver's license?" And I said to the tower contractor, I says, "Everybody's got a driver's license. What's the problem?" "Oh, not these guys. They're all drunks. They've lost their licenses." And the contractor says, "And I'm not a chauffeur service either. If they're going to come by and work, they also need to be able to drive a truck."
Wow. Well, so they might need a commercial driver's license, a CDL.
Oh,
to do that. Yeah.
But you have to have a license, you see.
Yeah, exactly. And they didn't not have a license because they couldn't find the DMV or they didn't know where that was or couldn't pass it. They probably had a license, but then had some DUI convictions and lost their license. Is that what your friend was saying?
That's the crux of it. That's where he's at.
Wow. Oh, wow. But boy, more and more equipment that broadcasters use, and of course that plenty of other industries use as well, whether it's a wireless ISP or, of course, cell phone companies, two-way radio companies, which seem to not be as popular as they used to be with the advent of pretty cheap cellular technology. The point is, there's a lot of equipment in the world that is 100 to 1,000 feet above the earth. A lot. And so I see no end of need for tower companies.
Oh, I absolutely agree. Although, quite frankly, I think that we're seeing a lot of short towers being put up nowadays. I live out in the sticks, and traditionally all of our cell towers have been like 500 footers or more.
Right.
But it's amazing, the little ones that are going up now just to create smaller cells. Regardless, there's a lot of tower climbing going on out there.
There sure is. And as I said, not likely to get any less. And that means I realize building towers, especially for the cell industry, will come in fits and starts. There will be busy times and there will be very slack times. And things like the television repack. Boy, that's going to result in an enormous amount of antenna work, moving antennas about, swapping out antennas. And plenty of people have predicted that there just aren't enough tower crews to do this on the schedule for the repack that is in the phases that it needs to be done in. So anticipate some problems there.
Well, I wind up with a language barrier with the tower climbers. None of them know anything about capacitors or resistors or anything. I have them go to a tuning box halfway up a tower. Well, turn on the capacitor. Well, what does it look like? What color is it? Don't you know what a capacitor is? How about a coil? Don't you know what that is? It's just like they have no experience in the world to anything to do with broadcast engineering. They just show up and climb, and some of them even have trouble picking up the right end of a screwdriver. And that's my experience.
Hey, you mentioned something pretty interesting there, and I want to follow up on it because it'll just about dovetail into some of our printed topics. And that is, you said a tuning box partway up a tower. Now, I've heard of this, Mark, but I've never engineered for a station that had a split tower or needed a tuning house. I assume you mean an AM tuning house partway up a tower. Tell me why you would have such an arrangement.
Oh, I'm thinking of one particular one where the box would detune the top of the tower. So the tower was 400 feet, and then there was another 100 feet on top of that, and there was a box at an insulating point between the two sections that needed to be adjusted to detune or isolate that top section of the tower. This is an AM tower. You know, this AM technology is far more difficult than FM, if you think about it. Even the transmitters are twice as difficult. You have twice the parts in them. You know, and AM is where we started out our life. Well, except for Morse code, that was. But then besides that, the point is that AM was it, and FM simplified things big time. But
okay, so this AM
wants to put, you know, we've got vertical real estate, and everyone wants to use these AM towers. Oh, just put it on my tower, not thinking. Now, wait a minute. What are the ramifications of putting something on an AM tower? Go ahead.
Right. And for and we have occasionally we have some young engineers, new guys, girls listening to this show. You know, with an AM radio station, the tower itself is the antenna. But with almost every other service you can think of, FM, cellular, two-way radio, STL, microwave, the antenna is mounted on a tower to get the height that you want. But for AM radio, the tower is, that piece of structure is the antenna. And so any changes that you make to it are you know, affect the AM transmission, the impedance, the characteristics of the antenna. So let's go back to this tower that you said was 400 feet with another 100 feet on top of it, and that top 100 feet was electrically insulated. I guess there were, you know, insulators on the legs of the tower, right? What kind of gear was at the top 100 feet of that tower?
Oh, a couple of FM broadcast antennas, and they had isocouplers at that point. And we just wanted to make sure that the top of the tower was not an AM radiator. And then you say, well, now, how do we figure that out? Well, here's how you figure it out. Let's say that the tower is a certain resistance at 400 feet. Then, if you increase the height of the tower, in this particular instance, the resistance would increase. Okay? So there I am with my impedance bridge at the base of the tower, and I'm saying, tweak on that vacuum variable capacitor, and I'll tell you if you're going in the right direction. And so we wound up with a situation where I went through a null as they crank the variable capacitor, a null a minimum of resistance, and then I knew, oh, I've got it now. There we are.
So the tower itself that contained the FM antennas at the top, I take it that was taller than was optimal for the AM radio station's operation. 400 feet was a great height. They didn't want the extra 100 feet for the AM, but they wanted to get the FMs up high, right?
That is correct. That is correct. And if the top had been included, the AM radiation, much of it would have just gone off into the sky. So instead of being pushed down along the ground where you want the AM signal to go, it'd go off in the sky and interfere with somebody 500 miles away. But what about those local listeners that you'd like to talk to?
Yeah. And this is an interesting concept, and I got to learn about this a long time ago, seeing those drawings of the vertical radiation pattern of, say, a quarter wave antenna, or a half wave antenna, or a 5/8 wave antenna. So this is different heights of an AM tower versus its frequency gives you a certain, if you will, a certain launch pattern. I like to think of it this way: if you have a frisbee and there's an optimal angle at which you can throw it that it'll go the farthest. You throw it lower than that, it'll go shorter, but you may be throwing it to somebody who's nearby. But there comes a point when you throw it up really high that all it does is either come right back to you or drop nearby. And that's a little bit analogous to what's the signal that comes out of an AM tower. You want it to be at the optimal launch angle and below to cover the people in your coverage area. Too high, and it doesn't do any good. It just, as you said, it launches off into space. So the problem comes when you have when your optimal size AM tower for what you want to cover is too short for the other things you want to do with that piece of steel, that real estate that you have that's pretty precious. And so you build a top on top of that, you insulate it, you put your FM antennas up there, and then you detune that top part, which, Mark, I always thought of that as detuning is making it look invisible to the radio waves. Is that a good way to think about it?
Yes, absolutely. But it only happens at one frequency, the AM frequency. So you're adjusting it to make it happen there. And oh, by the way, you mentioned towers. I like to think of antenna efficiency. Let's say you have a quarter wave tower and you put 1,000 watts into it. If you had that same tower, if you had a 5/8 wave tower in that same spot and you put 1,000 watts into it, that's the same as putting 2,000 watts into the quarter wave tower. It doubles the efficiency of the tower.
Now, does it double the efficiency of the power that's put out, or does it double the efficiency of the power that's put out in the place you want it to go, which is along the ground?
Okay, it's going along the ground as opposed to going into the sky.
Okay.
So it doesn't.
Yeah, because
the power isn't wasted. It's just a matter of where it goes.
Where it goes, yes. Yeah. So AM radio station power that's put up at a 45-degree, launched in that direction, just really doesn't help much, does it?
Especially after sunset.
Yeah, it hurts. It hurts. Doesn't help at all.
Okay.
So I have one more question about this tower you're speaking of, because, again, I never got to work on one of these. And you said there were 2 FM antennas on that top part. And I know there's coax that had to go from the AM tower across those insulators up to the part of the tower that you don't want. You want to be invisible to the AM. How did you prevent that coax from being a part of the AM radiator?
There is an isocoupler in each one of the 2 lines. So it's actually a couple of loops that look at each other. The transmitter's on one loop and the antenna's on the other inside this box. And the FM energy is coupled from loop to loop. And then, so what's the consequence for the AM? Well, there's about 50 to probably 100 picofarad of capacitance from end to end. So if you didn't detune the top of the tower, then that capacitance would be a way for the AM energy to be coupled to the top of the tower from the bottom of the tower.
Okay. So this thing called an isocoupler, and man, I used to deal with them pretty often, but I'd always deal with them on the ground because we were getting an FM signal onto what you'd call a hot AM tower. So there's an insulator at the bottom where most AM towers have an insulator. Whereas you're speaking of a tower that had insulators, most of the way up the tower, holding up the very top part. So I never thought of putting an isocoupler way up high, but obviously that's what was done.
Every situation seems to be unique, and in AM they get awfully complicated so many times. You just wish you could. Someday we won't have any more AMs. We shouldn't talk that way, should we? And then a lot of our problems will go away. But it's an art to know what to do with an AM. Yeah,
sure is. I live 4 or 5 miles away from WSM, 50,000 watt AM, and they have this enormous tower. Of course, their frequency is 650 kilohertz, so it's at the very lower part of the AM dial. So the wavelength gets longer, so the tower is really high, and the tower is about a 5/8 wave tower, but it's one of these Blaw-Knox brand towers. It's a diamond-shaped tower, and all the guy wires just go to the middle. So the bottom half of the tower, which is, 350 feet or so. The bottom half of the tower is guide at the top of the bottom half. And then the top half of the tower essentially is freestanding. It's a freestanding 4-sided tower that is, as if that midpoint was the earth where it sits, So that's a pretty interesting arrangement. Do you have any diamond-shaped towers in your stable of AM stations?
I do not, but I visited one of those towers, and it's WLW in Cincinnati, and it's right near the Voice of America station. If you want to look that up, if you go to my MW Persons website and look up engineer's log and go down to, let's see, May 20th, 26. No, I take that back. May 21st, 2016. You'll see pictures of WLW's transmitter site, a Blau Knox. But here's the part that interests me the most. There's an insulator at the bottom, and it not only handles all the weight of the tower, but horizontal stresses. Let's say there's a high wind at the high altitude part of this thing. It's going to want to push that tower over from this little diamond point at the bottom, the insulator, that doesn't happen to be metal. It happens to be ceramic. And if you know anything about ceramic, they break. So I don't know how they do that.
Oh, it's all that compression. Well, of course, the guy wires in the middle, if they're the wind on it, now, of course, wind at the bottom half would put more pressure on sideways on the insulator than wind at the top. Well, not more, but it could be the same. Mm-hmm. But the point is you got the guy wires in the middle that turn that horizontal pressure into downward pressure, and we know that ceramic does great in compression mode. It doesn't do well in a torsion or twisting mode.
Well, any tower worker will tell you that the wind is blowing up at altitude, whereas it's usually nice and calm down on the ground. Well, that means that the forces up on the top are going to want to push that tower and push the base in the opposite direction at the same time. And you think about tornadoes, bad storms, this could be something. How they keep them standing, I don't know.
Well, a couple of stories about that. I'm told that the WSM tower, again, that Blau Knox diamond design, actually was twisted by a tornado that passed near it, and twisted a little bit. And they determined that it wasn't a problem. But it definitely has been affected by that. And WHAS in Louisville, Kentucky, I believe they are 840 on the dial. They used to have a Blau Knox tower, which did fail in a terrible thunderstorm. Maybe there was a tornado with some straight line winds, but it did fail. And I always thought that maybe it failed with the pin between. Typically, there's two insulators on a big tower like that are back to back, and there's a pin between them. And I thought maybe that pin sheared. I don't know what happened. Somebody told me that no, the tower got lifted up and then it came back down and missed the pin. I have a hard time believing that the tower actually got lifted up, but it certainly could have sheared that pin. Did you ever hear about that WHAS tower?
I have not, but there was a radio station out on the East Coast, and it's the Tower Builder book. I loaned that to my friend Buck Fitch. Do you know Charles Fitch, a consulting engineer?
I don't know his name. Who is that?
Oh, wonderful guy. And if you ever get him on your program, he'll talk your ear off. That's the only problem. I call him on the phone, and I say about 5 words, and then I sit back, and 5 minutes later, maybe I can say something. So he's a wonderful guy and extremely knowledgeable, and I'm going to try and connect you.
Okay, that'd be if you would make a email introduction, we'd be glad to have him on the show. Charles Fitch, right?
Yeah, Avon, Connecticut. Wonderful guy.
Okay.
And I told him that I wanted to talk to him on ham radio today, but guess what? He says, I've got such a bad cold, I sound like Darth Vader.
Oh, no. All right. Well, why don't we move into some of the topics, more of the topics that you want to talk about? I appreciate this quick excursion into AM tower theory. That's so interesting. And you're right. And if you are an engineer who comes into a new situation, whether a contractor or a full-time engineer, in fact, Tom Ray in New York State, a former co-host on this show, former regular. Now he is on once in a while. Tom posted a question on Facebook about a Potomac AM19A antenna monitor for a multi-tower directional array. I mean, we're talking about an old piece of gear here, and he was having a problem with its logic circuits, not knowing when to take a sample, when not to take a sample. And this stuff is getting old, and very few people know about it anymore.
Now, watch it when you say that. I remember installing one brand new when the box was new years ago.
What is it you were doing? We were talking before the show. You did something in 1964.
Mm-hmm. I was 16 years old. and I helped my folks build their second radio station. The first one, I was just a preteen at the time, and it was WELY in Ely, Minnesota. The way it came down was my father started out in broadcast engineering in the 1920s. He went to WEBC Duluth when it was so new that they couldn't even hardly pay him to begin with. He had to have a second job just so he could work at the radio station. But things came along in the 30s. They sold advertising. He started getting paid. They built a half a dozen radio stations in Minnesota and Wisconsin. And finally, it got to be one of those corporate jobs where, it was just eating him up. I mean, it was like stomach ulcers, so he had to quit. And so he went to a place where there's almost nobody, Ely, Minnesota, and built a radio station there. And it was his one and only radio station. And so he could be there and do radio without being bothered by the corporate structure. And so later on, when I was 16, as I mentioned, I helped build a radio station in Brainerd, Minnesota, here, with a BC1G Gates transmitter. You remember we have Gates now? Well, we used to have Gates back then, too. You might know
exactly. That. and plenty of engineers have worked on the original Gates, as I have and you have. And I don't yet have any experience with anything with the Gates Air name on it, but I'm sure at some point I probably will.
Sure. And no tubes left in them either. Oh, wait a minute. No, Gates Air. Don't think there is still an FM that they have with one big tube in it.
Really? I didn't know that.
Yeah. But, I mean, you're talking 20 and 30 kilowatt stuff. And so the component count is down. But and the cost will be down a little bit. But, the solid-state stuff is catching on so fast that and the components are getting bigger and bigger so that you need fewer and fewer of them, that tubes days are really numbered. And don't mention that to the folks at Econco, but that's just kind of the way the world's turning.
That there are plenty of industrial uses for tubes that more than I know about, that are going to keep Econco in business for a while. Hey, Mark, we got to take a quick break right now to hear from the folks who are my employer, the Telos Alliance, and something that you really ought to sign up for because it's free. Go right ahead.
Not much in the paper today, is there?
Not much. Seems tough to stay informed,
Like we're missing out on stuff, important stuff.
Yeah, feels like week-old news. Yesterday's stories. Half the tech stuff in here seems out of date by the time I see it.
What Kirk doesn't know is I'm way ahead of everyone else around here. Every Thursday, I get this newsletter in my email. It's Direct Current. The folks at the Telos Alliance publish this.
What Joe doesn't know is I keep one step ahead of the radio guys in this market. Every Thursday, I get Direct Current from the folks at the Telos Alliance. It's a free newsletter about radio engineering, audio, streaming, studios, everything.
Thursday afternoons, we have our department head meeting. I look like a genius, thanks to the knowledge, updates, and advice in Direct Current. Sometimes I wonder if I should tell Kirk about Direct Current. Might help him out.
I wonder if I should let Joe in on my secret. He could use a little help sometimes.
Nah.
Get Direct Current in your inbox every Thursday. Read profiles of engineers and newsmakers in the broadcast community. Get technical pointers putting you and your facility at an advantage. Important industry news and views. Plus, you'll be up to date on Telos, Omnia, Axia, and Zipstream products. It's all here in the Direct Current newsletter. Subscribe online at telosalliance.com/directcurrent. That's telosalliance.com/directcurrent.
I just got my new Direct Current in the email today, and of course there's a couple of product updates on some Telos things. There is a little quickie interview I did with a really old guy, morning man, in Cleveland, Mississippi. And remember Chris Tarr? He was a co-host on our show for a while, and he's been an occasional guest. And said there's a feature about Chris Tarr about this protocol called SNMP that I ain't figured out yet, but Chris sure has. He really has, and there's an article about all the cool things you can do with SNMP and how to get started on it. Also some thoughts about streaming. So check it out, Direct Current from the Telos Alliance. follow the link in our show notes or just Google Telos Alliance and Direct Current. You can sign up for that newsletter. You'll be glad you did. All right. It is This Week in Radio Tech, our 328th episode. Chris Tobin is traveling today, and Mark Persons is with me here. Mark is coming to us from his beautiful home and office in Brainerd, Minnesota, where the temperature this morning was what?
Oh, probably around somewhere in the teens. And guess what? Friday night, -4. That's 4 degrees below zero, not 4 degrees below freezing.
Wow.
But this is Minnesota. That's just the way life is here.
I'm guessing you and Paula have closed the pool up for the season.
The pool and our lake, the body of water behind us, just happens to be frozen solid. Thank you.
Ah, it is. Okay.
But we can walk across it in the wintertime. So
I've always wondered if there's anything in the radio communications ham radio genres that you can do with a frozen lake that you can't do with a non-frozen lake. Ever thought about that?
Well, we could investigate that, couldn't we?
Could you
I'll tell you that I do know a story from communications from expeditions to the North and South Pole, and they found that the ice is really an insulator, and so they couldn't use it that way. So they had to build antennas. They could lay them on the ice, but they couldn't use them. You couldn't drill a ground rod in and expect to get ground out of it.
Really? I did not know that. Okay. So you have to build
another interest. Oh, go ahead.
No. Well, you have to build a cantilever ground if you want to have a ground. You can't have a earth ground.
Cantilever ground.
Well, maybe I'm using the wrong word. Sorry. You've got to make a ground plane out of some kind of radials. Yeah.
Okay. Well, that's if you want a vertical antenna. There are antennas called ZEPs. And where did they come from? Zeppelins. Amateur radio guys would tell you all about that. They're long. They're just single wire antennas that just absorb the energy. You don't need another path. But that's a whole different story unto itself. But there's another story about going to one of the poles, and there was a bad shield connection on the microphone, and there was hum in the microphone. And here you are 1,000 miles from the nearest power line. Well, it turns out that the 60 hertz in our electric grid goes everywhere. It just travels around the globe. So you can have hum in a microphone at the North Pole.
Wow. So people who think that they're sensitive to 60 hertz fields and live a sheltered life out in the middle of nowhere, they're not really doing themselves much good. It's everywhere.
It's everywhere. It's everywhere. You remember Chicken Man? He's everywhere. He's everywhere.
Yes, exactly. We played Chicken Man on our station in Samoa. What a segue. We paid for and played Chicken Man there. It was great. Great. So American Samoa, you've mentioned real quickly something about, we have some of your equipment. If people don't know all the stuff that you do, and one of the things you do is you build some custom or semi-custom equipment for radio stations, I guess, on order. Yeah.
Well, being a guy who works with his hands and a ham from the age 16, I mean, it's just normal to build things and make them, and so I've got a machine shop and I do all the soldering and all of that, and so I build little things, relay panels for EAS or whatever it turns out to be, and I built many hundreds of them, each one at a time. And then I keep in the file, I keep what I call recipe cards. So if I want to do another one, then I go to the recipe card, and then I say to the client, well, do you want the same thing or do you want it a little bit different? Well, then I just build whatever he wants. So everyone's usually fairly unique. But it's just a fun thing. How many people do that today? How many people have a drill press in their shop? How many have soldering stations that keep constant temperature on solder? How many people know how to solder? That's a whole different story.
Yeah.
Go ahead. Yeah.
We actually, at the Telos Alliance, we actually do a little bit of machine shop work and building custom panels. for our trade shows, because sometimes we need a panel that just isn't made. But and of course, over the years, plenty of engineers have built things out of bud boxes and panels. I've made a few things that didn't look nearly as pretty as the ones that you make, probably because I wasn't using a drill press, hand using a drill. And decades before that, I know I keep referring to WSM down the street here, but in their transmitter building in the basement is a huge machine shop with a what do you call it, a brake press for bending metal and a huge metal lathe and bandsaw. They used to build transmitters and parts for transmitters just down the road here at the WSM transmitter site. It's incredible. Lost
Makes
art.
perfect sense, And when I visited out in Bethany, Ohio, for the what do you call it, the Voice of America, they had a machine shop too, and that's what they did, was they had to keep transmitters running. They were built in the 1940s to send audio to Europe. It's just huge. There's a whole story behind the Voice of America, but they did it very successfully.
So I want to promote that you make these relay panels. Now they're just simple relay panels, so they're for carrying analog audio, or you could switch EAS audio, but you wouldn't have any synchronization in the switching. We use them at our stations. In fact, at my stations in American Samoa and in Greenville, Mississippi, where we're all Axia, we're all audio over IP. We come out of audio over IP system to analog, go through your relay panel that you custom built for us, and you can enable or disable whichever, because we have multiple stations in both towns, and then we go back into the Axia system for distribution to wherever we're going. And that, on the one hand, a lot of engineers don't want to come out of the digital system and then go back in. Today's equipment that does that, whether it's from Axia or from one of the other companies that makes this kind of gear, the A to D and D to A conversions are really, really fabulous. I mean, they really operate down at 24-bit audio. Then they do math that's no worse than about 20 bits. You're really getting really good audio. Now, here's my point. We are able then to do switching on the output of our Axia nodes that feeds to your EAS panel. That's where we do our key program switching, so that we can put a different studio on the air just by switching what comes out of that port that goes to your EAS panel. And we do that a lot. Sometimes we'll be on automation. Sometimes we'll be on the studio. And so we have to switch daily, several studios and several transmitters. And we do that just by telling the output of that Axia X node what to do. But this goes in this output, no matter what it is, it goes and feeds your EAS panel, comes back in the system, and then is distributed to transmitter sites, or it's distributed to our stream encoders. So we get equal switching there too. It ends up being really easy. Anyway, I just want to give a plug to your EAS panels because they're simple and they work fine.
That's very kind of you. And oh, by the way, you've really described it well. But the interesting part about the EAS, it's the last thing before you go to the processor, of course, and the transmitter. In other words, you can't supersede an EAS alert. It has to be there regardless. You can't bypass it and do something else. So that's
you're right.
And the panels would allow one EAS encoder decoder to handle maybe 10 radio stations, and the switches allow you to EAS test one at a time without testing all 10 at the same time. Can you imagine that? Right in the middle of commercials and people saying something, and there's the EAS test.
Well, and it turns out that we have one market with 5 radio stations in a single building, and those 5 stations have very approximately equal coverage areas. So we interrupt with the same EAS information on all of them because we're not running stations with different coverage areas. Oh, they may catch part of a county here or there, but we've just programmed our EAS to catch all those counties that we're responsible for and interrupt for all of them.
Great.
You want to mention something about KHJ in Los Angeles, AM stereo, and you had some interaction with Jim Lupus on that, right? Back in the late 80s?
Mid 80s, somewhere in there. And sure, he called me up and he said, would you come and install this AM stereo gear? And I said, well, that's great. And it's in LA. I happened to be in California because I was building another station in Salinas, Monterey at the time. Well, that's just a short drive down to LA. And I had lived in LA as a early teenager, thereabouts, and so I knew the stations. At 930 KHJ, that was, of course, one of them there. Now, 5 kilowatt, fine. It's not exactly a biggie, but it's on the low end of the AM dial, so it got over Los Angeles very well. But it was funny for me to show up there and do AM stereo on it, and with a unique 3-letter call letter set. I'm heard later that they changed it to four letters and then went back to the 3. I would never let go of a 3-letter call. Just like on my amateur radio call, W0MH, that's a 1x2. Who would want to leave one of those and go to a longer call? Silly.
Yeah.
So anyway,
I hear you.
So I don't know if they're still running AM stereo, but let me tell you a quick segue here. Mm-hmm. I learned recently that if you have an HD radio in a car, that it is actually programmed to listen to AM stereo. That it's it was set up to receive standard analog modulation, and by chance they put in the AM stereo decoder. But the funny part is, they accidentally reversed left and right channels when they instituted the software implementation in the HD radios.
What? Oh my goodness! So you can, if you have an AM stereo station, you have a car radio that does HD, and we assume it does AM HD as well, which very few people are transmitting. But it should pick up AM stereo, but left and right reversed. Yeah. Wow.
Funny.
Hey, left, right, reverse. I'll tell you a little thing that happened to me, and maybe you had something similar. When I was a fresh, young, inexperienced engineer, somehow I got the job being the engineer for WKQQ FM in Lexington, Kentucky, 98 Rock Double Q back in those days, and big album rock station. Nice turntables, first in the market to get CD players. And one day I had to do some kind of maintenance on the phono preamp. And so whatever I did, when I hooked it back up, I accidentally swapped left and right, coming from the tone arm down to the standalone phono preamp. I swapped them, and I didn't, really think it mattered and didn't think about it. Until the next day, several people had called and said, hey man, the drums on that song's on the wrong side, man. You need to switch that around. So, wow, I got an education real fast that people care about this. So
that's great.
Easy fix, but I learned something.
Now, back in the early 80s, I built a brand new AM stereo radio station at Cape Coral, Florida, 3-tower directional. And I took great pains to make sure there were no transformers in the system anywhere. Okay. Audio consoles, STL, audio processing, the whole business. And in the audio consoles, I put gain tilt on the microphones. And here's how it works. Okay. When just one announcer has his microphone open, then he's on both left and right channels simultaneously, as you would expect, right? But let's say that the second microphone is turned on. That's the two-headed morning show, that kind of thing.
Okay.
As soon as that second key was opened, it put the announcer, the main announcer, on the left channel and dropped him somewhere between 3 and 6 dB on the right channel.
Okay.
Vice versa for the other guy. So let's say you're driving to work, and you're listening to the radio, and you hear the main announcer in front of on your left, and then the second guy on your right in the car. So they're talking back and forth, and it feels spatially like a really cool thing.
Huh. Now, of course, you didn't pan them hard left and right. You said you left part of it in the other channel. So it may have been panned, I don't know, maybe half over one side, half to the other.
Yeah, and the key there was that the audio processing this is a CRL processing of the day. Remember,
right.
CRL was the king of audio for AM and AM stereo of the day, and it had something called mono gain support. So somehow it finagled away so that the mono listeners never knew that there was less audio on the air.
Right. I remember that. Yeah, mono gain support was absolutely there, and single channel limiting was in there too.
Yeah,
remember that?
Yeah, it all got very complicated, and I was too busy building phasers from the ground up and working on transmitters to fully understand what some of those terms were. Mm-hmm.
Let's move on to this subject that we teased earlier in the show: this car radio and volume and detents, and what your experience has been, and I'll preface it just by saying that I've got a thoroughly modern cell phone here. It's a Samsung Galaxy S7, not the Note 7, but the S7, perfectly legal on airplanes, and it's got the up-down volume controls, and I've noticed that sometimes I can't get the volume to be exactly what I want. It's either too loud or the next click down is too soft, and we as broadcast engineers familiar with better quality equipment over the decades, this is a little disturbing to us. Tell us what you found.
Well, no kidding. We grew up in an era where a volume control was an analog device. And if it didn't get scratchy on you and create a lot of extra noise, you could just bring up the volume in the tiniest increments, up or down. And now we're into the digital encoding, where you have a radio dial in the car with these little tiny mechanical detents as you go along. Well, and each one of those positions, there's nothing in between. It's either one or the other. And I noticed that Ford, when they first implemented the sync feature by the young guys at Microsoft, they didn't know any better or care, or their ears didn't care at all, because 7 decibels was the incremental step between one level and another, and then another 7 dB and another 7 dB. And for them, it probably sounded just fine. But what about us old guys, and especially broadcast engineers and people who don't hear well, like me, and that's way too big a jump. So they fixed it. They changed it to 4 dB, and that's still too much change from one to the other. It should be 2, in my opinion. So I did a study of what other manufacturers are doing. General Motors cars, I found 2.5 dB per step. What about Bose? 1 dB per step. My, that's nice. I could set the volume anywhere I want. It's true. It was written years ago that the average listener can perceive a difference in 3 dB steps. And I can easily hear that 3 dB step. And quite frankly, 4 dB is way too big. It just becomes uncomfortable to listen to. Either it's too low or it's too high. And cars are very noisy environments. So you need to get that right just to feel good about the programming on a radio station.
Now, I thought the definition of 1 dB was the minimum perceptible change in audio level. So 1 dB ought to be the minimum. In fact, I'll relate a story to you in just a minute, but about 1 dB and why some audio processors implement tenths of a dB in changes, because there's a reason for that, even though 1 dB is the minimum that supposedly a person can detect a change in. But go ahead. So 4 dB, there's plenty of chance that I'm not going to be able to get the volume that I actually want at that time.
And I look at it as a software revision, and I'm probably wrong about the 3 dB being the perceptible difference. It's probably 1 dB. I know that I can hear 1 dB difference, so maybe the average person doesn't care, but I do, and it makes a lot of difference to my enjoyment in listening to a radio.
So at the Wisconsin Broadcasters, you and I got to reconnect there a few months ago in October. One of the things that Frank Foti talked about in his talk was about this thing of why do we have tenths of a dB in the output control of an audio processor. And he explained that, and I intuitively I knew this, but he really explained it in a way that really brought home the idea. And here it is. Natural audio that's not processed, indeed 1 dB is the bare minimum change that people can hear. And sometimes it would take 2 or 3 dB to say, oh yeah, that got louder. Oh yeah, that got softer for natural audio. But if you take processed audio, first of all, let's think about a radio processor. So you've got either an AM or an FM processor, and it's doing wideband AGC, multiband compression, and then final limiting, and then final clipping. And you move that a dB, well, that's 10% modulation at the high end of the scale. So a tenth of a dB is roughly 1% modulation, and you can hear this when the audio is really screaming, when it's pumped up loud and it's as loud as it's going to be, and you move it a tenth of a dB, that is just about perceptible. Certainly 2 or 3 tenths is perceptible. So that's why an audio processor, like an Omni is going to have tenth of a dB steps. But here's where that relates back to today's music and why this is even crazy. The thing that you're bringing out here, 4 dB steps, is crazy because so much audio we hear from a car stereo, whether it's from the radio or from an iPod or a Bluetooth music source, it's all been processed, sometimes harder than we'd like to hear. And that 4 dB is just a crazy amount to change the volume of a processed piece of music. So that's my thought on it, and Frank said it, and I agree.
I absolutely agree, and I hadn't thought of it that way, but it makes perfect sense. It really does. And all the Ford has to do is just a software revision. All these cars run on software, All they have to do is issue, they've issued several already, and all they have to do is say, well, here's another one. Just load some software, easy enough to do.
My wife has a Jeep Commander, and it's got an entertainment system that if the car's in park, the driver, the front seat, can watch the DVD that's playing for the kids in the back. But as soon as you take it out of park, the screen removes the movie and shows you the radio controls or the map. And you can load third-party software in that box to let you keep watching the movie while you're driving. Not that it's a good idea. And that you can also keep the backup camera on all the time if you wanted to. And anyway, you're right. It's all software in these things.
Okay.
Yeah.
So that might not be so good.
We've got time, not for much more, just for a little bit. I'd like to hear this FM Extra idea as the last thing we hit on, if you don't mind. Could you tell us your thoughts about FM Extra?
Okay, this is where you use a subcarrier on an FM radio station, just as we use 67 kilohertz and 92 kilohertz for background music years and years ago, or telemetry or whatever. Well, instead, you'd fill up that baseband with a digital signal, and you could have 3 or more audio channels on there that are digitally encoded. And guess what? The station didn't use any extra bandwidth. It just used existing bandwidth. So no additional station, no additional interference to any adjacent stations at all. And the technology was cheap. It was like $12,000 for the box. And then you own it, and there's no licensing fees. And it worked great. I put it on a station one time, and they had wonderful coverage with it. It wasn't quite as big as the analog coverage, and I don't have the the exact facts in front of me. But I thought it was a wonderful example of how to use up the baseband that's beyond the 53 kilohertz, from the 53 kilohertz to the 100 kilohertz on the baseband that's there anyway on an FM. And it didn't require any special anything to make it work. Just plug it in, tune it up a little bit, and away you go.
Yeah, I thought this was a fantastic idea. In fact, back in 1988 or 89, I'm not trying to take credit here, but I envisioned putting digital signals in the FM baseband. I had no idea how to do that, and I talked to a couple people, and nobody really knew about it either. And then a few years later, obviously somebody else was thinking about it. Out came FM Extra, and it worked. I guess maybe the problem with it was there wasn't a potential for any company to make boatloads of money on it, and all of that maybe they could have, and so there was only one or two radios that were ever made that would pick up FM extra.
Yeah, and the radio didn't have to be very expensive; just had to have a little extra and a decoder in it, and no licensing fees. How convenient, huh?
Yeah. That's something that I really wish would have taken off. It would have been great for so many things. We may not have had HD radio then, but this is so much simpler, seems to me, than HD radio. Now, it may have had the problem of it didn't have the redundancy that HD radio has built in, but it didn't have the complication either. Maybe it didn't need as much redundancy.
And you didn't have to add any extra transmitters to add the digital. You didn't have to didn't have to change the bandwidth of the radio station. It just played.
Yeah. I mean, we should. I would love to get in touch with and have on the show some people who were involved originally with FM Extra. That would be pretty cool. Hey, we're going to take a quick break. Mark, when we come back, we'll have just a minute for a tip for you to pass along a tip to our listeners and viewers, something that they can maybe put to use in the next week or two as they're doing their engineering jobs. So if you would, try to work up a tip for us, even if it's go to your website and read your good stuff. Hey, our show is brought to you in part by the folks at Lavo. You know, most of you know me as a broadcast engineer and on-air personality and the host of this show. But what you may not know is that I've also sold broadcast equipment internationally. Now, that job took me all around the world, and really I have seen a whole lot of control rooms broadcasting in lots of countries and the different imaginative ways that people do the things that they do. And one of the reasons I'm excited to introduce you to our sponsor, Lavo, LAWO.com. You want to go to their website. There it is on the screen, LAWO, but pronounced Lavo, it's German name, .com. Now, Lavo's famous around the world for television, audio, and video, especially for high-profile event coverage like the Olympics, World Cup Soccer, and the Grammy Awards. When the broadcast is mission-critical, you're pretty likely to find a Lavo console there or even other Lavo infrastructure. You wouldn't believe how this stuff is built. Now, everything is over-engineered, redundant. Even their backups have backups because there are no do-overs in this live event broadcasting. And dead air, it'll kill your career. Now, you might be thinking, why should I care? I'm not doing TV. This is a show about radio. Well, radio guys hate dead air even more than TV guys. That's what we've got. So broadcasters like NPR, CBC, BBC, to name a few, buy Lavo radio consoles. Now, being this involved in TV and radio around the world means that Lavo thinks a lot about the future. And everybody knows that all types of media are converging into a common IP-based delivery platform. Lavo is ready for it with broadcast gear that can handle audio, video, and control of every studio device using a single integrated commercial off-the-shelf computer network. And after that, well, here comes virtualization, broadcasting from the cloud. Lavo's already building those tools as well. So if absolute bulletproof reliability, 5 nines of uptime, and being future-proof are important to you, well, you owe it to yourself to find out more about Lavo. Now, here's a special website for TWiRT listeners and viewers. I want you to go to this website to check it out. Check out lavo.com/TWiRT. So LAWO.com/TWiRT to find out more. Lavo.com/TWiRT. Thanks a lot to Lavo for sponsoring This Week in Radio Tech and having our 5,000 listeners and viewers hear about Lavo and their technology. All right, we're about to finish up our show with Mark Persons. He's been our guest here, and always interesting stuff to talk about in depth. And that's why I love having these conversations with Mark. We ought to have him on more often. And Mark, do you have a tip to pass along to our listeners?
Oh, yes, of course. The tip of the day. That's when you're going looking for a used car and you go to the dealer and say he gives you a handful of keys and he says, go out and look at the cars on the lot, you know. And what you do is you don't even take them for a drive. You get in the car, you turn the key, turn the radio on, and look at all the presets for what stations the previous driver was listening to. And if it's symphony music and that kind of stuff, you know that the car has been nicely driven. But if it's wild rock music, you probably don't want that car. It's been beat up. There you go.
So wait a minute. If you pick a car that the presets are on classical or fine art stations, there's something else you better do. You better check the light bulbs, because it's probable that the turn signal's been left on a lot.
But at least the engine's in good condition.
Actually, we have a show title. Check the turn signals. Oh, man. Oh, that is great. That is great. Yeah.
I look forward to seeing you again someday soon.
Good. Do you think you'll be at NAB?
Yes. Yes, I'm planning on NAB this year.
Good deal. Well, you should be there. And hey, I would encourage you to, I don't know if you want to, but I've enjoyed being on the SBE board of directors, and I was just newly elected to that. So, man, you ought to join me on the SBE board.
Well, I hadn't thought of that, but I put in my application to be a mentor to other broadcast engineers. They haven't assigned me to anyone yet. Hopefully it's a nice young lady or something, but it wouldn't be here. It would be by telephone, by the way. So anyway, we could use a few women in broadcast engineering, and I would be glad to tutor someone, anyone, man or woman, because, gosh, the industry needs broadcast engineers desperately.
Amen to that. That is so true. And that mentoring program, in fact, we'll do a show on the mentoring program coming up. Mark, we got to go. Thank you so much for spending an hour with us and our audience here at This Week in Radio Tech. Please give my kindest regards and happy holidays and Merry Christmas to your family, to Paula, and anybody else that's important in your life. We sure appreciate you being here and glad you are.
Same to you and yours.
Okay. All right. Our show, This Week in Radio Tech, brought to you by the folks at the Telos Alliance and Direct Current e-newsletter. Check it out at telosalliance.com, and brought to you by the folks at Lavo. Go to lavo.com/TWiRT to find out more. Special thanks to Suncast, our producer, who makes things happen at the headquarters, the big headquarters in New York. And thanks also to Andrew Zarian, founder of the GFQ Network, where you'll find lots of other fine podcasts, including What the Tech. We'll see you next week. And next week we've got, I believe we've got Dana Popolo finally going to be on the show next week to talk about FM antenna tuning and how critical that is. Plus, he's got some ideas for a shoestring STL. If you really don't have any money at all, Dana's the guy to talk to. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.